then, folks. Hello, and welcome to today's SQL Office Hour session. Today, we're going to be continuing the kind of Back to Basics series that we started last month. This time, we're going to be talking all about update and see how you can change rows in your database. As always, it's great to be here. This is your chance to ask questions, so please put questions in the Q&A window. I'll take several opportunities throughout the session to stop and review what's been asked there. So please do that, and we'll have some debate and discussion, hopefully. So hi, everyone. I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team. It's my job to help you get the best out of the Oracle database and hopefully have a bit of fun whilst doing so. So with that in mind, let's get started and start talking about update. So first up, we'll just cover the basics, the basic structure of an update statement. So it will look something like this. You're just saying update, what the table name is, and then set, and then a list of the columns that you want to change. And then optionally, you can have a where clause. You pretty much always want to have a where clause, otherwise you're going to change all the rows in the table. Probably not what you want to do. Right? So a few little details on this. So first up, when we supply the new values, they overwrite the existing values in the table. So we set col1 equal to val1 or v1, that's what its new value is. And the update does that for all the rows where the where clause is true. So we can update many, many rows in the table at the same time with an update statement. I'll talk more about that later on in the session. And there's another important thing to be aware of when you run update statements. So when you start running an update, you lock the rows. So that means no one else can update the same rows at the same time as you. It also means they can't delete them as well. So what that means, if two people are trying to change the same rows at the same time, one person will win, they'll be the first person to run it. Second person's got to wait for that first transaction to finish, to commit or roll back before they can proceed with their update. So that's kind of the basics. We'll dive into some more of the details as we go on. Now, first thing I want to cover off is something we talked a bit about in last month's session on insert. We've got to provide a list of the columns we're going to update here, but what if the table you're changing has got a lot of columns, right? Let's say you want to update a couple of hundred columns at the same time. Clearly, writing out a big set list with like column 1, 2, 3, 4, 5, and so on, it's a bit of a pain. So it'd be nice if there was some simpler ways you could do that. And the good news is there is. You can use, just like with insert, we can do record type inserts, we can also do record type updates. So you can declare a variable which has the table sent row type, so it includes all the visible columns in the table, and then we just do set row. So that changes every single column, every single visible column in the table. So it's a little simplification, but there's a lot of gotchas here, and some of them we've talked about last month in update. So first up, there are issues if you've got invisible columns and virtual columns in this table. So the invisible columns will not get changed as part of this update, and you can't update other virtual columns, so the statement will fail if you've got them. So I talked about this in detail a lot in last month's session when we were covering insert. If you want to know the details of that, then just review the recording of that to kind of get into more in the ins and outs of invisible columns and virtual columns and record-based updates. So that's with so that we can use that to update all the columns in a table. And in last month we talked about insert. One way I said to kind of avoid this problem was you can actually just create a view. So you could create a view of the columns that you wanted to insert to simplify the syntax. And you can actually do the same with update as well. You can create a view which contains only the columns you want to change, and then you can do this record-based update. You say set row equal to the view record, where it's sent row type. This works great with insert, but you probably don't, or you're probably less likely to want to do this with a view. Why? Well, all the columns that you need to access must be in the view. So that includes the ones in your where clause. They will also get updated or changed as part of this update. So it's generally not really a good idea to update primary keys. Not only does this give your database more work to do than it really should, there can be various issues with missing foreign key indexes, foreign key locking, and so on. So you probably don't really want to do this. We can use a view to shrink down the list of columns we're actually changing, but the columns in the where clause still need to be in that view, and therefore they will still get updated or changed as part of this record-based update. Even if it's like a no-op update, they're still included in that. You probably don't want to change those. So does this mean these record-based updates, dead in the water? There's no hope for them? Well, we can also actually update a query as well. So we could write a query like this. So you just do update, and you have essentially an inline view selecting the rows that you want to change and the rows and columns you want to change. And we can actually do a record-based update like this. So here, we need to create our own record of the columns we want to change. So that will be the ones we want to set the values for and exclude those in the where clause. So we could do this, but as we'll see in a minute, it's quite a lot of code. So it's debatable whether or not you want to do this. It's worth mentioning as well, this little updating a query like this, you can actually use this to update a join as well. It doesn't just have to be one table. We can there are limits to how interesting the query can get. I'll show some examples in a minute, but you can actually update a join too, should you wish to. So at this point, that's enough slides to start off with. Let's jump over to a little demo. So what I've got over here is a table of accounts. And we can see we've got this in session 1. So I've got 2 sessions side by side here, so we can see what's going on. And this will help show that when I change a row in one session, it is locked, and therefore the other session can't change it. So what I'm going to do is I loaded this table up with some random data. So we've got some kind of junk email addresses and stuff in there. I'm going to hijack one of these and make it mine. So I'll set the email address to my work email address, and we query that afterwards. We can now see the email address has changed. Now this change is only visible in that first session on the left here. We go back to the second session, it cannot yet see that change because the first session hasn't committed. So it won't see the newer email address until we commit back over in this first session here. So let's try and update the name as well. So in the first session, I updated the email address. This session, I'm going to update the name to make it my name as well. I'll start executing that, and we'll see the statement is blocked. It's just stuck here waiting for this first session to commit or roll back. So even though we're changing a different column in the table, it's the row itself that's locked. Okay, so we can still have blocking updates, even though we're actually affecting different data. So this is blocked. So to release this, I need to go back over to my first session here and then commit it. So let's just commit that, and we'll see, hopefully sort of pretty much straight away, the second session then completed as well, and we changed the row. So if we query back over here in the second session, we'll see it's got the new name and email address. So because I committed that first change, we can now see it is visible. We can't see that change in second session yet. I'll just go on the first session, I say, getting mixed up between these. We'll see it's still got the old name. Got to wait until I commit here before we can then see that change over here again. Okay, so very important thing to be aware of. When you change a row in one session, you will lock that, and no one else can change that row until you end your transaction. So let's move on, and let's look at some of these kind of record-based updates. So what I'm going to do is I'm going to update every single row in the table, doing something like this. So I've got a row type variable, and notice I'm just setting the email address, login, full name. I'm not setting the user ID, which is the primary key. So what's going to happen when we run this? It's all going to fail, right? Because I haven't supplied a value for user ID in this record. So it tries to update that primary key value to null. Obviously, that doesn't work because primary key columns have to be mandatory. They are implicitly not null. Yeah, okay. So that means we need to supply its value as well. So even though we're not actually changing it, we still need to supply its value, even though it's staying the same. We need to provide that value for every single column in the table, every single visible column in the table. So let's run that, and we can see now we've completed, we've actually executed that update, and we've changed the rows. So as I said, you probably don't really need or want to update every single column in the table most of the time. You might have some forms where you change a lot of the columns in the table, but it's very rare. In fact, you know, if you need to update the primary key column in a table, there's probably a problem with your data model, right? You shouldn't really be changing those. And there's probably a lot of other kind of metadata type columns which you don't really want to update as well. Things like inserted date. Once you've inserted it, that should never change. So you don't want to have the risk of someone actually coming in and changing this. So what if we want to update lots of these columns? We want to do a record-based update, but we don't want to update every single column in the table. Well, we can declare a record like this. So I'm just going to change the name and the email address here. So I'll declare a record with those and use the nice little qualified expressions we've got in 18C. So this record now has its own implicit constructor I can use to initialize that. I'm going to select the columns in the record in the update statement, and then this will just change those columns in the table. So this will now run, and it's changed just those two columns in the table. So let's just update that and set that. So let's say whether or not you think this is better than just writing an update out with a set clause, it's kind of, you know, up to you. You have to think about trade-offs of having whether it's worth creating this extra type and so on. Some situations will be really useful. Other situations it won't be useful at all. You really got to decide which way you want to go. I mean, record-based inserts I think are great and can really simplify things. Record-based updates, it's a bit trickier. The case isn't quite so clear as an advantage, at least for me. I mean, if you've got other opinions or thoughts on that, please let us know in the Q&A and let me know what you think about this. Okay, so we can use this update query to do a record-based update like this. So we've got this row keyword. But as I said, we can also do things like update other types of queries, but there's a lot of restrictions around what you can do here. So what I've got here is I've got a table of accounts, and there's a one-to-many relationship for that of account logins. So basically, the idea here is I've got my account. Every time I log in, we'll insert like an audit record, essentially saying that I've logged in. So we'll get a big list of those. So there's a one-to-many relationship from accounts to account logins. So if we run this query, we'll see we'll get what have I done here? Why is that not worked? Oh, it's because I've not got my data for some reason. Oh, sorry about this, folks. This is going to take a long time to run. Okay, let me just quickly, I will, while you wait for me to just sort this out, anyone got any quick comments or questions while I do this? Let me just run an insert here just to do, because I'm sorry about that. My update must have failed earlier. We've got this insert must have failed earlier. We've got this one-to-many relationship, and it's not going to work because I'm trying to update the last login time for the account with the login details from the from that child table. And we've got a one-to-many relationship. We're trying to update the row in the one, but we've got many. So many into one doesn't really go. So the database doesn't allow us to do that. So notice we can actually set one column from the other in the subquery. So I can't go from the many to the one, but we can go from the one to the many, or at least kind of. So if I flip those around, so updating the login date time from that and try and run it, we'll see it actually executes, but we've got a unique key violation because the primary key of this account logins table is the user ID and the time they actually logged in. So we failed there. In theory, we could do this, but in this situation, it doesn't work. So if we go back to this example, what we're saying is we kind of want to store on the account record itself the last login time, so we can find that information really quickly. So, a lot of websites, they have a little thing that says you last logged in at this date to, verify that it's you, like you can remember the last time you actually logged in on the site, all right? Anyway, so we want to show that on the accounts table because it will fetch that information anyway, rather than having to go through possibly hundreds or thousands of records for the account logins. So it's nice and efficient. So we might try and do something like this, actually aggregate the rows up and just find the latest date I was actually, I did that. So we'll run that, and it doesn't allow us to do this. So we cannot have a group by in here. So while in theory, you can do things like this, like I say, there are a lot of restrictions around this. So in practice, you may find that a lot of those don't work. All right, so that was the demo for now. Let me just, I'm just going to get this repopulate this again, because I think I need it for later. So questions or comments on that before I go back to the slides? Okay, so we can use this. We have an update to change rows. And you've done your insert, you change your data, you query it back again, and find something strange has happened. Your change is missing. Okay, so this is actually a real problem that you need to watch for, and that is a lost update. So this is when you've got two people changing the same rows, not quite at a similar time, and one person overwrites the other person's changes. So we'll look at what this is, why it's a problem, and how you can resolve this. So let's take a little example. So let's imagine we're just kind of going across from time here. We've got two users here. So let's say I'm querying my account record. I fetch my details out. I can see my email address, my username, my name, that kind of thing. So I want to do that and work with my data. At the same time, there's someone, admin, some back-end engineer or something like this, is also querying my records, because they're going to do a data cleansing operation or data modification. They're not actually going to change the data as such. They're just going to change how it's stored, uppercase my name, because they haven't learned how to do case insensitive search yet or something like that. All right, anyway, so I've selected my data out, and I want to change my email address. So what I'm going to do is I'm going to flip, instead of chris.saxon, I'll be saxon.chris. So having queried that, view that in my application, I will then change the email address and send back to the database the information. So that's my email address and my name, because they are both in the form. So that's fine, I run that. But shortly after I do that, or around the time I do that, this admin also writes change to the database. They change my name to uppercase, but they're not going to change the email address because they're not interested in that. They're just doing some data cleansing or something maybe here. And notice this update, their update finishes after mine. So what happens when we query the rows back out? Well, we will see the changes from this second update. They will overwrite the changes that I made. So what does that mean? I've lost the change to my email address. This could be quite a problem, because email address is quite often used as like your login information, right? If I've changed that because I've lost my email account, or it's been compromised or something like that, and now someone else has overwritten that change, or have I just lost access to my account? Maybe. So this isn't good. So this is the classic lost update problem. Two people read the data at a similar time. They both change different fields in that data, push the changes back to the database, and one of them overwrites the other's changes. So this is a classic lost update problem. So that's what it is, and how do we solve it? Well, there's two basic approaches. We can use optimistic locking or pessimistic locking. So what are they, or what's the difference between those? Well, pessimistic locking is where we prevent other people from changing the data at the same time. So what we're going to do is we're going to select the data, but we're going to select it for update. So this blocks other users from accessing the data at the same time. They can query it, they can just run normal queries against it, but they can't update it or select for update it themselves. only the first person to run this statement can do this. So that's the idea with pessimistic locking. When I query the information, I select it for update so no one else can change it for the duration of my transaction. Now, the really important thing to note here is, in order for you to do this, it must be a stateful application. So this rules out most, if not all, web applications, because your query or your transaction where you fetch your details, that is one transaction. When you then go to change it, you then start a new transaction to the database. The web is a stateless environment, has no state. So that means you're spread across two transactions. We need to have it all happen in one transaction to use pessimistic locking. So how can we avoid the lost updates in these stateless environments? Well, we use optimistic locking. In that situation, what we have is we've got some kind of version marker in the table. So this could be last updated timestamp, could be a version number column, it could be a hash of the data that we've queried out. There's various different approaches you can use to do that. The key thing here, it's something that is in the data beforehand that we are not changing, that we can then use when we write the change back to see if there has been a change at the time. And this is the approach that you've typically got to use in most modern applications these days. You've typically got to use optimistic locking because pessimistic locking requires state. So let's look at pessimistic locking in a little bit more detail. So we're doing a select for update here, and you see I've got option, you've got this no wait or wait n. That's to ensure this times out essentially, because as soon as I run that, this then blocks other select for updates or other updates, other deletes of those rows. So anyone else trying to change those rows will be stuck and won't be able to do it. So that is blocking other people from running that select for update. Now, key thing here is after running that, the person who's going to make the change actually needs to look at the data and need to say, okay, these are the rows that I'm going to change. That is the current state of the data. I'm happy with it. I'm going to change these columns and push that change back to the database, right? Because only one person at a time can do that. Only one person can see it in that select for update mode, and they know that their changes are going to persist. So I said we've got this select for update. No one else can get that into that transaction commits or roll back. So you almost simply want this no wait or wait n, because that means if someone else has already locked the data, you'll get an error, right? So no wait, you'll get it straight away. It'll instantly bomb out if someone else has locked the rows for whatever reason. With wait n, we can have a short wait, maybe a second or two, rather than just kind of instantly bombing out if the row happens to be locked for some other reason at that particular time. And this is important because potentially someone could have that row locked indefinitely, right? If any of you worked on old forms applications and things like that, where you've got like you can open a row and have it mark your intent to actually change it. I forget what we actually call it in forms. There's a mode where you can do a select for update for your row in form. People can then leave the form in that state and like go to lunch and have that row locked for a long time, or maybe they'll do it at the end of the day and forget to commit their changes and lock the row out for several hours. A bit of a problem if other people are trying to do this and everyone can then get stacked up behind them. So there's no wait 10 is a good approach to make sure people aren't waiting indefinitely, so that if someone else does have the row locked, then you can identify that problem fairly easily and sort it out. Tell them to actually commit their transaction, end their transaction. Now, you might also want to take this approach when using optimistic locking as well. You might still want to use select for update before you do an update as well. So a couple of reasons for that. First up, as I said, you've got to do the update, you've got to wait for other transactions to complete. If there's some back-end job or something like that that's running, which has the rows locked for a long time, you don't want users to be there waiting for this to finish, so the select for update can tell them that it, come back later, change your data because there's a problem. Secondly, and this is something I talked about way back in February, I believe, if you have multiple updates or deletes in the same transactions, you can end up with deadlock scenarios. So if you've got 2 or more updates, or an update and a delete, or lots of DML transactions generally, you need to be very careful to avoid deadlocks. Select for update locks all the rows at the start of the transaction and can avoid that problem. So in some scenarios, regardless of this pessimistic or optimistic locking, you'd want to do a select for update to ensure that you can actually change the data. Okay, so that's pessimistic locking. What about optimistic locking? As I said, what we do is we query the data, you get the row hash, could be a timestamp, could be a version number, whatever. It's some information that, some metadata about that data that we are then going to check when we actually try and update the row. So I've queried that, I've put my changes into the form, click submit to send it to the database, and that's going to run the update, change it, and it'll check that that row hash or timestamp is equal to the one it had when I selected it back out. So key point here is this update also needs to change that hash or timestamp every time we change, so that we can detect the data has changed since we last queried it. So we know that it's not safe to do this. So which would you use here, row hash or a row timestamp? You could use version as well, but I'll just focus on timestamp and hash just for time reasons really at the moment. So the big advantage of using a timestamp is there's a very, very good chance you already have a last updated date column on that table, right? So you likely have this for audit reasons. Very common to do this, so you know when someone changed it, so you've got some information. So it's very likely you already have this. You probably don't need to make additional data model changes. And even if you don't, there's still value in actually adding this for other reasons other than optimistic locking. However, that means any change to the row will essentially invalidate the update. So if I'm querying my data, my account record, I want to make some changes to it. And in the meantime, there's some background process which also changes that data, updates the timestamp. When I come to submit and actually make my changes, timestamps won't match and it will fail, but it will fail for spurious reasons because that background process, it's not changing user data, it's not changing information that matters to me, it's changing, I don't know, updating that last login time column or something like that. So the timestamp is all or nothing. Any change to the row will be picked up and will reject it. With a hash, on the other hand, we can just limit it down to the particular columns that we're interested in. So we've got a form which has 2 or 3 fields in it. You can build a hash on just those fields and ignore the rest of them in the table, right? So if there's a background process or other user which is changing different information at the same time as we're doing it, they can actually coexist. 2 different transactions can update different data without causing optimistic locking problems. So and hash has that big advantage there, whereas timestamp is everything. So that's kind of the big drawback of using just a timestamp. Also applies if you've got a version number column. Secondly, with the timestamp, to be sure that this actually stays up to date, it's quite likely that you need to rely on triggers. Now, of course, in theory, you shouldn't have to do, and in theory, everyone should write an update that includes the last updated thing, set it to sys date or sys timestamp. In practice, we all know that doesn't happen from time to time. So to be sure it stays in sync, you need a trigger on there which sets that if someone has not supplied it. So as we'll see later, that can have a performance impact. So there's the downsides of timestamp. Well, what about hash? What about the downsides of using a hash? Well, it's just a lot bigger overhead compared to a timestamp. So it's a larger, the data type's larger, so we need more storage if you're actually storing it, and computing a hash is more expensive as well. So I'll discuss that in a bit more, but basically, if you really care about performance, a hash might be a little bit too much overhead for you. Timestamp is more lightweight, and like I said, you probably already have it anyway. So whichever of these you use, you'll update it, you'll change the user data. You'll also change the timestamp of a hash. You probably want to know what the new value is, the value for the new timestamp or the new hash after it's updated, right? So you can return that, you can keep it and return it to the client or whatever. Nice thing about update is it, like insert, has the returning clause. So we can say values from which columns we want to collect and keep them into variables. Now, big advantage update returning clause has over insert. So we can actually use this to get the values from many rows. So if we've got an update which changed lots of rows, we can use bulk collect to collect them all into an array. Or if we just want some summary information, we can actually use aggregates as well. So we could do things like return the total, the sum of the rows changed, the maximum value for the particular column that was updated, and so on. So with the returning clause, we can get values from multiple rows once with this returning clause. And this is where I'm going to jump back to a demo. Hopefully my insert is finished, which was actually loading that information in. And hopefully that is all finished now. Yes, that's done. Good. Yes. Let me just make sure that's committed. Alrighty then. Before I get into this, just see a comment or question from Judith. Oracle Forms did this in a very clever way by issuing select for update only when there was an attempt to edit the row. And then it was compared to the currently displayed previously fetched values and to the current values, and an error was raised. Yes, that's it. It was a good piece of functionality, and certainly any of you've used or developed Forms applications will almost certainly be aware of this functionality. And it, as Judith says, it was very nice and very useful. And because it was a stateful environment where you kept your you could do it all in one transaction, pessimistic locking worked really well there. Unfortunately, those days are kind of gone, really, and we need to use optimistic locking typically. All right. Okay, so let me just go on with the demo. So first thing I want to do is I'll just set everything to set my name and email address. Okay, and we'll just fetch that information out and do it in both sessions. So you can see I've got the same information in both sessions. So here we'll do the classic lost update. In my first session here, I'm going to change the email address. So I'm flipping my first name, my family name, given name around and the email address. So we'll run that and I'll then complete that. Over in the second session here, so this is the backend administrator, whoever it is, email address stays the same, but they're changing the formatting of the name. We'll run that update, commit that, and their change has persisted, right? We've got the uppercase name, but my change is lost for the email address. It's back to the original email address, Chris Saxon, rather than Saxon Chris. If I go back to my first session again, we can see lost update. And in this case, it's probably quite tragic because, you know, if I'm using email address as my login method, I could be locked out of my account here potentially. Not good. So, and there's just lots of other scenarios where, well, generally it's just not a good situation to be in. You don't want people to unknowingly overwrite other people's changes. So let's look at pessimistic locking. I'm going to do a select for update in my first session. So I'm marking my intent to change this row. I say I want to change this row. And in my second session, at the same time, I'm also going to try and change this. I say I want to change this row at the same time. So I do a select for update, but bang, I'm not able to do that because the first session has it locked. Okay, resource busy. So now the second person knows someone else is trying to change this information, come back at a later time and try again. So now in my first session, I can go back and I will change my information. Actually, I should probably change that to the, I'll change my email address, I'll change the format of that, change that, save that, and we can see we changed it all back again. Okay, and if I query back over in session 2, again, they can now see that change. So that was pessimistic locking. We did a select for update to stop other people changing the rows at the same time. Optimistic locking, I'm going to create a hash here. Well, actually, I'm going to sort of show both. So I'll have create a function which takes the name and email address. They're the only things that are in the form, and we'll return a hash of those. I'll then add a last updated column, and I'll use a virtual column for the hash. So I'm not actually storing it. So just add those to the table, and I'll create a trigger to set the last updated time to make sure nobody forgets to do it. Right. Okay, so we create that trigger. So let me just reset everything back again, ensure it's back where we were. And if we fetch the details, they'll both see the same thing, like exactly the same row. The key thing to notice here is we want to look at this hash. Okay, what's going on there? Can we get that to look a bit bigger, a bit nicer? Oh, it's not showing me. Let's drag that over so we can see that row hash there. So they're identical. So we've selected that out, and that will be a hidden field in the form. Now I will come to change the data, and this time I'm just going to change the name format. But notice I'm also comparing the hash. Check that it is equal to what it was equal to before. So it is in this instance, so that will execute, and I'm going to return the new row hash and updated date as part of it, and we can see we've changed that row with a new hash. So that update worked. We'll go back to my second session. Flip things around here, but this is changing my email address now over on the right, and that was changing the format on the left. I'm going to try and run this, but again, it's looking for that row hash that I selected out again. That has now changed. So when I run this, in this instance, I've got a check here that says nothing updated, and it will say nothing updated because the hashes do not match. In your application, you might want to change this to raise an application error or something like that and say, data's changed since you last queried it, try again, here's what it looks like now, try again, that kind of thing. So either way, good thing here is I have not overwritten the changes here. Okay, so I've still got the changes that we had in this first session here. Okay, so we're not overwriting each other. And I did that with this hash, but I could also use the last updated timestamp. So just a quick kind of like comparison of some of these overheads here. I said hash had a bigger overhead. So we compare the size of them. So I've just got a date for the last updated date. So that's 7 bytes. This is 20 bytes for the hash. As I said, I'm not actually storing the hash here. It's a virtual column, but you might want to actually store it. Why? Well, if we just query them, with the virtual column, we're actually going to execute that function at runtime, query time every time, and it takes quite a bit longer to actually fetch it. Okay, so there are more overheads with this hash compared to the timestamp. Uses more storage, needs more space if you're physically storing it, and it's slower to compute than just the basic timestamp as well. So no, although it's quite a bit slower, that's averaged over 100,000 rows. So that's nearly 2 seconds versus less than 20 milliseconds. But each individual execution is still really, really quick. That's just under 19 microseconds versus 1 microsecond. So you probably don't need to worry about this really, unless you're really trying to juice every last ounce of performance out of a system. The system with low updates, you probably don't need to worry about this. Focus first on what functionality matters. Do you want to only worry about lost updates on a subset of the columns? If so, you can create hashes on those. And yeah, you could actually create multiple hashes. So I could create one based on the email address and name, and a separate one based on the login time, and maybe there's some other information I want a different hash on as well. So think about the functionality you want first, and then worry about these performance details later, because they're probably only going to matter at really extreme scale anyway. So UDIT, in extreme cases, a hash collision may prevent the hash mechanism to detect changes. You would have to be mega, mega unlucky for that to happen, UDIT. I mean, while theoretically you're right, in practice, the chances of 2 rows having the same hash for different values of these and the the primary key or whatever your lookup values, they're just so vanishingly small. It's effectively impossible. Consider it, but it is vanishingly unlikely that this will ever actually happen. Well, if you've got questions, please put them in. While you do that, I'm just going to talk a little bit more about this returning clause. So as we saw here, we could use it to return the row hash or the last updated time. It's particularly useful for these, so we can return it to the client. they want to change more, update other information, we don't need to requery the data. They've already got the latest information, so we can use that to do the detect the lost update again, second time around. But as I said, we can actually use this to fetch the values from many rows that we're changing. So here's just a bit of a naughty update. I'm just going to increment the last login time for 10 users, and I can bulk collect them into a record. So I've just collected simple index associated array with that type, and we'll run that, and we'll get all the rows, and there we go. We can see we've got all details from all the 10 rows. So very useful in some scenarios if we want to use that for processing the data later on, that kind of thing. But as I said, you could also use aggregate functions in here. So we don't care about the details. We just want to know how many rows we changed and what the last login time is. So we can do that too. So we can return those as well. And you see that's the information we got there. Now, do note, while you can use either of these, you cannot mix and match them, right? You can't use an aggregate and bulk collect. It's one or the other, not both at the same time. But either way, these are potentially very useful ways to get information about the data you just updated. All right, I'm not seeing anything at the minute. Oh, very quiet today. Is this, am I covering stuff that everyone knows, or is it just, so hot everyone's like, oh, or am I covering it so well that we've got no questions whatsoever? Anyway, okay, let's go back to the slides. So we talked a bit about the basics of update, locking rows, and avoiding lost updates. Let's look at another common question that comes up. What you've got two tables of data, and you want to update the second table using the values from the first. Okay, so this is quite a common question. And the basic approach a lot of people take to do this is something like this. They'll have a cursor for loop, which selects the values from the first table, loop round, and in each iteration, it will update the inner table. And I will admit, the first production update I wrote was actually something like this. Okay, it's a lot of people kind of like, I remember thinking at the time, it's like, well, I've got these rows to change, and I hadn't really learned SQL. I'd learned C. I'd learned how to program C, and I was like, well, you've got like a list of things you need to change. Well, how do you do a list of things or get through that? Well, you iterate through it, you loop through it. So a lot of people will try and do this when trying to change many rows in a table, particularly using another table as the source. This is absolutely not the way you should write an update, okay? What you want to do is change all the data in one statement. So to see why, we'll talk a little bit about performance, okay? So when you've got a statement like this, what we're just going through is changing the rows one at a time. We're picking a row up, changing its value, going on, picking the second one up, changing its value, next one, changing its value, the next one, changing its value, and so on. That is not the way to write nice, fast performance SQL. What you want is one statement that changes all of the rows. So how do we do that? Do that here? Well, what we need to do is we take this select query in the cursor for loop, and we need to put it in both the set clause and the where clause. So we put it in the where clause to find which rows we're changing in the update. But because it's also providing the new values, we also need to put it in the set clause. So we end up with a statement that looks a little bit like this. So I see a comment from Rachel, I lost a weekend that way once, yeah. Having an update in a cursor for loop, easy way to lose lots of time. Actually, first time I did this, that prediction code, I'm still not quite sure how I did this, but somehow I managed to actually make the loop an infinite loop. So not only was it slow, but we actually had to kill the whole process because it just locked the whole database out effectively. And yeah, so very common junior mistake to do this, or beginner mistake, is to write an update like that. What you want is to write a statement like this. So as I said, notice we actually have two subqueries here, one to find the rows in the where clause and another in the set clause to provide the new values. Downside of this is we've now got that driving query twice. So we're reading that same data from the source table 2 times, doubling the amount of work we're going to need to do. So yeah, that could be a bit of a problem. Another thing here is as well, there might be many columns that we want to change in the target table, and there's lots of columns from this source query. Well, we can actually do that. You can actually update all of them with one update set thing like this. I'll show you how in the demo in a minute. So this is like the recommended form of this. But as I said, we're reading the data twice, and you can still find that this is actually really slow, particularly if you're changing lots of data, okay? If you're changing significant fraction of the rows in the table, or just a large amount of data normally, even if it's a small percentage, this can still take a really, really long time. So can we do any better? Well, yeah, there's several things we can do. One thing we can do is we can avoid reading that source table twice by turning it into an insert update only merge. So merge is typically used for insert if not exists, update if does exist logic. So an upsert type logic. But the insert and update clauses are both optional. You have to supply one or the other, but you don't have to supply both of them. So we can do an update only merge, which means we're only reading that source data once, which can give a good performance advantage. But running this, it could still take quite long. And you're like, oh, this is still taking really long. I want to go faster still. Now we're updating a significant fraction of the rows in a table. How can we do that? Well, there is a little trick we can do. What we can do is update into a temporary table like this. So we're going to run a query which selects the original values from the target table and the new values from the source table and load those into a temporary table. We then need a process to switch these two over. So this probably means we need an outage to do this. A couple of reasons. First and most obviously, to switch tables over, there's going to be a brief period of time when either one of them's empty or we're reading from the wrong table or something like that. To avoid problems like that, you probably need an outage. You can use addition-based redefinition to avoid this, but that's getting beyond the scope of what we've got time for today. But the second problem is, even if you can take a brief outage to swap them over, that's only a short time period. While you're actually running this create table to supply the new values, if the application's live, any other changes to that table will be lost, right? So you've got a snapshot of that data, you've started creating it. Anyone who starts inserting, updating, or deleting data after that point, those changes are lost when you switch those tables over. Yeah, so a couple of problems which make this impractical to do when the application's online. So you almost certainly need an outage to do this. At which point you're kind of like, well, that's great, but I can't take an outage, or at least I don't have the window for a long enough outage to actually do this safely. Well, what else can we try? Well, there is a little known trick. So there's in DBMS redefinition, there's this execute update procedure, which you can use to actually pass it an update statement. So this allows you to run that in an online manner. So to see how this works, it's best I'll go for a little demo and I'll run through some of these examples here. So first up, I'll just show you the data here. What I'm going to do is I've got about 50,000 rows I'm going to change here, and I'll start with the naughty way of doing it. We'll do a cursor for loop, and we'll start this running. And as I said, this will just go around and do 50,000 updates table. And as you can see, it's taking a little while to execute. So that's finally done, and it took 10 seconds, 10.5 seconds to complete. Let's just back that out. Now, if you remember earlier, we said we would create a trigger to maintain the last updated time. Well, now's the reason why you might not want that trigger. If we remove that, because every time we update the row, we're also executing the trigger, that adds some overhead. If we remove that and get rid of it completely and push the change of the last updated into the update itself, you can see we've saved quite a bit of lot of time already just removing that trigger. So triggers can cause all sorts of horrible nastiness, but the big thing to watch out for is the performance overhead of executing them. As much as possible, you want to push the logic into your SQL if you can to avoid these triggers. So we've got a good saving there, down 10 seconds down to 6, but that's still a little while. So let's see if we can do a little bit better here. So what I'm going to do is run my update like this. So I've now just transformed it all into a single update. So I've got my set clause fetching the values, and I've got exists here. I mean, you can use in or exists. The kind of which you use is kind of personal preference, really. The optimizer doesn't really care these days. You can optimize both of them. So we've done that. We've turned it into a single update, but actually, you probably noticed that still took a little while. And if we go back here, it actually took a bit longer than the cursor for loop. And you're like, hang on, you're telling us that cursor for loops are super slow, single statements are nice and fast. What's going on here, Chris? You've just made it slower. Well, looking at the execution plan in a bit of detail will hopefully make this clear. So first thing, as I mentioned before, we're reading the data twice from this account logins table. So we're having a double pass that data, essentially. But also, if we look, we've got a nested loops here, and that subset subquery, we're actually running it once for every single row in the account table that we're going to update. So it's actually logically very similar to that code we just wrote. Loop through all the rows that we're getting from the accounts table and run the subquery for each one of those. Okay, so it's not too fast here. So how can we do better? Well, if we turn this into a merge, we're now reading that account logins table just once. So you notice we can have a subquery here to find the last date for each one. We'll run this, and hopefully we'll find it's a little bit faster, do a bit better. Okay, so that felt a bit quicker. I'm not sure what you think, but it felt a little bit quicker to me. Let's have a look and see. Yeah, down to 3 seconds, 3 and a bit seconds. So we've halved the runtime again. And looking at the plan, you can see we're accessing accounts and accounts logins just once each. So we're not double counting these account logins, which can give big performance advantage. Okay, so that's nice. But let's say we still want to go faster. Let's say 3 seconds is it's still too slow. Well, as I said, we can do an update into the table. So we're going to select the last login time from the table. We will create the table, run our update like this, and hopefully this will be, down to shade under 2 seconds. So we are even faster again. So that was super quick, but now we've got to do the switcheroo for the tables, which, as I said, there's lots of practical reasons why you might not, it's tricky to write, lots of practical reasons why you may not be able to do it. So that is where I'm going to bring in this DBMS, the execute update procedure. So to do that, I'm actually just going to create a temporary table to load this into, because we can't use the virtual columns for DBMS redefinition. I don't want to worry about the child records and so on and so forth as well. So I'm just creating a temporary table just to show the principle. All right, so in my second session here, you'll see I've actually just got my update that I had further up here. It's basically identical, the same, and we just pass that to DBMS redefinition, nice and easy. So we'll start executing this, and that will run away and start going. So while that's executing, back in my first session, I will just change the data a little bit in that temporary table. So let's just commit that, make sure it's all committed. So I've added one new row, mistesting, deleted 10 rows, and updated a whole bunch of others. It's a new name. Just make it nice and obvious that something has changed here. So the key thing here is that these changes will be saved when DBMS executes, DBMS redefinition finishes. There is a line in the documentation which says these changes will be overwritten. That's complete nonsense. Hopefully it will be fixed soon. You can have DML in another session and it will be persisted, but only changes to the other columns. So columns we are changing here, the updated date and the login time, those changes will be persisted after the DBMS redefinition, but the changes will overwrite any changes to those columns, but we're not going to overwrite any changes to other columns or deletions and insertions that we make. So we've run that, and that's now finished. And if we go back over here and query our accounts table, you can see that those changes are still there. So we can still see we've got our user mistesting we've inserted, we've still got the new names. And because I wasn't updating every single row, I'm only updating people who logged in after this date, you can see that some of them still have the original login time that are on the new login time that this set today. Others have the login time were overwritten with this one. Okay, so DBMS, despite what the doc says, and we hope to have this fixed soon, you can run them at the same time. Okay, so it is safe to do that. So now, but some of you may have noticed, okay, we can do this, but this still ran for a really long time. That DBMS execute update actually ran for nearly a minute. All right, so you might be going, well, that's a really long time to run, right? So why would we do this as opposed to those faster updates? Well, if we're just doing a regular update or a merge, we have to lock those rows. So the two potential problems. One is we run so long that we lock out users, application users, stop them from doing it, or background processes, application users are currently running updates, which means we can't run our merge or our update, right? So there could be concurrency problems there. This allows it quite often with update, it's not necessarily the problem that it runs for a long time. The issue is really that you're going to be locking those rows from a long time, which prevents normal application functionality from running, right? So DBMS redefinition execute update allows you to do this. Now, do note, however, while you can do this while other transactions are going on, you still probably want to do it at a quiet time. Why? Well, the way this works is it creates a temporary table, kind of does the update into that, but it also creates a materialized view log on the source table, the accounts temp table, to capture the changes. So once it's finished doing the update to the temporary table, it copies the changes from the materialized view log back to that temporary table and does a switch over. If you're doing a lot of changes in these other sessions, there's potentially a lot of work here for DBMS redef to do. Okay, the more changes there are, the more work there is, and the slower it's going to be. So you need to think a bit about that. Secondly, this process does briefly get an exclusive lock on the target table when the process finishes. So to do that kind of switcheroo process. So again, you might think very carefully about running this at some of your busiest times. If you've got a nice kind of quiet time, probably the best time to do this. Question from Rachel, does this work in 11G? No. So this execute update was added in 12.2. Okay, so it's a relatively recent addition to the family here. Alrighty then, we are nearly on the hour, but so if you've got any other questions or comments, please let us know, but I'll just recap and then we can have some time for a bit of chat if you want. All right, so running updates. So as I say, we run an update to change rows in the table. So you run your update and it overwrites existing values with the new, and while the update, it's not just while it runs until the transaction ends, those rows are locked, preventing other users from updating or deleting those rows at the same time. If you're not careful, this can cause problems, but in general, this is actually a good thing. Otherwise, you can end up with weird scenarios. I mean, if two people try and run conflicting updates at exactly the same time and the database allowed it, what would the end result be? Yeah, it avoids awkward questions like that. So something to be aware of. But whatever you do here, because update overwrites the existing values, it's possible that two people at querying and changing the data at similar times, they can both query it, and then afterwards both write their updates. They can overwrite each other's changes. It's called lost updates. You need to be very, very aware of what this is. and whether it's a problem. I'm pretty confident that actually the vast majority of applications I've worked on didn't really handle this properly and worked more by the fact that concurrent updates were highly unlikely rather than, good design, and they prevented it. So a lot of the time you don't notice this is an issue because it's unlikely for two people to change the data or the same data at the same time. Still should take steps to protect against it. You can use pessimistic or optimistic locking in a stateless environment, so web environments, typical today. You really need optimistic locking because fetching the raw data is one transaction, writing it is a separate transaction. However, the select for update aspects of pessimistic locking could still be really useful when you've got optimistic locking. Stop your transactions getting stuck because there's an uncommitted process somewhere, and it's also necessary if you've got multiple updates or deletes in one transaction of the same data to prevent deadlock, which is something I talked about a while ago. Finally, performance. As I said, you really want to avoid putting an update inside a loop. That is if you want to, well, I say you want to avoid it. If you want to write a really slow process that causes you to lose a whole weekend, as we've all done, I think, at some point, yeah, go ahead. But if you want it to be efficient and nice, you want to avoid that. Merge is generally going to be better than a correlated update, simply because we can avoid reading the data twice. And actually, correlated update typically actually works kind of like a cursor for loop in practice. So you want to look at that. Could also look at create table select or DBMS redefinition. I didn't talk about it today, but you could also look at using parallelism, either the default parallel, parallel DML, or use DIY parallelism to do that as well. If you want to know more, it's more reading links. So I've got some live SQL tutorials covering the basics of a update and tuning it, and of course I've always got my free SQL course on the Dev Gym and database for developers foundations, where you can learn a lot more about this. Alrighty then, yes, Rachel saying true story. I think we've all been there, Rachel, either as the person doing it or the person supporting it. So yeah, we've all been there, learned the hard way. Hopefully I helped some of you not have to learn the hard way, right? Okay. Okay, a few other questions have come in quickly. All right, so let's just take these quickly. So Hachemi, any advice about deleting rows which are not merged? Kind of fast sync table from another view. I'm not sure exactly what you mean there in terms of deleting not merged. I'm going to talk about delete. So next month's session, I'm going to talk about delete. So if you could give a bit more of a fleshed out example and submit it on the office hours page, then I can cover it in next month's session. Okay, but I'm not quite sure what you're getting at there exactly. I mean, merge does have a delete clause in the update, but there's some various things. It's not straightforward as you might think. Okay, I mean, we have to use the update. We have to update the retention ID for 40 partitions. So when we drop partitions based on retention ID, we do not drop something that needs to be kept. Is there a good way to do this? Again, I'm not quite sure what you mean there. I mean, we have to update the retention ID for 40 partitions. I mean, you can do update partition by partitions. So, if you want to, you can do kind of DIY parallelism. If you've got partition table, you can just update the rows in one partition at a time, and then you can update the rows in another partition, and you can have separate sessions run at the same time. You can submit a job or whatever to do them all at the same time. And because they're in different partitions, they can continue concurrently. My colleague Connor actually has a blog post. It's about inserts, but the principle's the same for update, showing you how you can do that. But I'm not quite sure. I'm not sure what the problem is. I'm not sure the problem with this drop. I mean, if you're dropping a partition, it's just drop, right? There's no where clause for drop. So yeah, okay. So Niels, doesn't DBMS redefinition bypasses the redo log? Yes, another good point, Niels, is when you use that execute update for dbms redef, it will minimize the redo significantly. So that's another consideration. Maybe some of you have run that massive update, and it wasn't so much the actual performance that was the problem, it was the DBA shouting at you because it's run out of archive log space or something like that. It can generate significantly less redo than a standard update. So that's another advantage it has, why you might want to consider it as well as just the concurrency of updates that you might want to do. Anonymous, what's the best way to update 2 columns on the one table from a driver table correlated subquery? Sorry, I was going to show you that. It was in the demo, but I didn't actually call it out properly. Yes, good point. So I've actually done it here. So you can update multiple columns. You need to put brackets around the columns in your set clause like this, but then you just list out the columns in your subquery like that. I've used sysdate, which isn't actually a column in the table, I'm sure you know, but it could be a column in the table if I wanted, right? So the point here is you just put brackets, put in parentheses all the columns you want to change, and then just list what their new values are going to be in the subquery, okay? So yeah, you can do that. And I meant to mention that, but I forgot. All right. So hopefully that answers your question, Anonymous. Rachel again, can you briefly discuss the performance aspects of using OR versus union all? Is there a solid rule? I hear a bit of unfortunate advice about this going around. What do you mean by unfortunate advice? Okay, this is one of those kind of it depends thing. So in general, the optimizer does tend to struggle with OR conditions because it can be hard for it to find the rows, and it depends on what you're doing. So if you've got a column and it's in a list, so user ID equals 1 or user ID equals 2 or so on and so forth, you're probably fine with just using standard in or. If you've got different columns, so if I want to update rows where the user ID equals 1 or the last updated time is greater than today, trunk sysdate, for example, so our OR condition is on different columns, again, the optimizer can really struggle to find appropriate indexes to find those rows efficiently. It quite often falls back on a full table scan. Now, fortunately, in some cases, it can actually kind of split that into a union all itself. So certainly if you've only got 2 of those columns, it is able to split that into 2 union alls itself. But certainly if you've got lots of different columns that you want to change here, you probably want to split that into separate union alls. If you want to know more about that, probably warrants its own question or going into a bit more detail in another session. So I mean, if one fails, we need to roll back everything. If one what fails, I mean, okay. I mean, are you talking about this retention update for our partition? I mean, yeah, you could, as I said, you can just update one partition at a time and commit that, so you don't need to roll back the whole thing. So you can update partition by partition. And that's one of the things that partitioning is useful for. If you want to operate on a single chunk of data at a time, and whether that be querying it, updating it, deleting it, whatever it is, accessing only the rows in a partition can be very useful. I mean, if you've got an example, if you can sketch out exactly what you're trying to do and submit it either on standard Ask Tom or on the office hours things, we can talk about that in a bit more detail. Okay. Okay, one last comment before we wrap up, because we've gone way over. Saving all the questions for the end, folks. All right, yeah, that's fine. So Oren, another alternative to merge with the same execution plan, update a query. Yes, it's a good point, Oren. Maybe you missed that at the start, although you can't always do that. I mean, that wouldn't work in this instance because we had one-to-many, and we were trying to find the most recent row for each one. Sorry, we didn't really cover that again, but yes, you can update a query, and if there's a one-to-one relationship, yeah, no worries, Oren. So an updated query like this can work in some scenarios, but there are a lot of restrictions on it. So it's worth a try. It's definitely worth a try, but don't be surprised if you hit one of the restrictions with it. Yeah, but yeah, thanks. No worries, Oren. Thanks for calling that out again. Okay then. We're way past the hour. So, but thank you all for hanging around and having some good conversations about this. Really hope you enjoyed this. More importantly, I hope you learned something. Summer's here, at least for those of us in the Northern Hemisphere. Hopefully, you're going to go out and enjoy your day. Stay safe, stay healthy, and hopefully we'll see each other soon. All right. Bye bye.